In this video, we're going to go over what inverse functions are and how to find the derivatives of inverse functions and inverse trig functions. Now, there are shortcuts, there are formulas you can use, but sometimes they're a little bit confusing, so we're going to show you how to derive them, and then you guys can decide what you want to do when you guys approach some of these problems. Okay, so an inverse function is a function that undoes what another function did. So for example, if your function was called cow and you put your input grass, you put that into the cow, what comes out of the cow, the output should be milk. Hopefully you didn't think something else. Anyway, the inverse cow, okay, so that'll be our inverse function. What we'll do, we represent that with a little -1. The input for the inverse function, if we put in what the function's output was, in this case it'll be milk, and we put that into the inverse cow, whatever that does, then we should get out whatever caused the milk. So in this case, what comes out of the inverse cow will be grass. Okay. The best example, but hopefully it kind of makes sense. Graphically, what we see here is that if we have a particular function, this is what you hopefully seen in your pre-calc classes, that if it's f of x, then you have a point, let's say 1, 4, then your inverse function, so f with a little -1, f of x, the point there will be reversed. So in this case, the related point will be 4, 1. So 1, 4 to 4, 1. Okay, so that's kind of just a real quick, fast review of what inverse functions, what happens with them. So we're going to take a look at one inverse function, and hopefully from here we'll be able to see kind of what the derivatives will be for this. So let's say we take a look at x squared. Okay, so here's this function x squared. It kind of looks like this all the way. So there's my x squared function. At this point right here, okay, so at this point right here, this point will be 2, 4. Well, if this is my function, then the inverse function should have a corresponding point. Here's the inverse function. It should have a corresponding point, and it does here at 4, 2. Okay? So every single one of these points on the function, if we reverse the x and the y, we will create the inverse function. Okay, so that's all fine and good, but how does that help us in calc when we start dealing with like derivatives? So when we start dealing with derivatives, we are going to be using like, for example, a slope at this one location, and we're going to see how it corresponds to the slope of the inverse function. So we're going to actually do some of the calculations here first. So let's go down to the bottom part of these notes. Okay, so we're going to calculate the derivative of f of x and f inverse. So for f of x, we have f of x equals x squared. So therefore, f prime of x, the derivative, the formula for the slope should be 2x. Okay, no surprise there. Now for the inverse function, so if f inverse of x is equal to the square root of x, then f inverse of x, if I put this in brackets, put a little dash here, this means the derivative, so that this is x to the 1/2. So all we have to do now is use the power rule, bring down 1/2. The new power is x to the negative 1/2, and if I wanted to read, it would look something like 1/2 times 1 over square root x. Okay, so those are my two derivatives. All right, so we know that at f of 2, and f inverse at 4, those are related points. So if we go back here, we know that these 2 points are related. Okay, they're connected. Now, we want to see how are their slopes related. So we have their slope formulas for each of the functions. So now we're going to plug them in. We're going to find f of 2. So f prime at 2, the slope will be 4. Okay, so that means that up here, the slope equals 4 at x equals 2. Okay, so we got that. All right, moving down. So what about the inverse function then? How does that slope, what will that slope be? So f inverse prime, okay, at at 4, that will be 1/2 times 1 over square root 4, which is 1/2 times is 1/4. So if you take a look at the slope for a function and the slope of its of the related point on an inverse function, you can see that there's 4, there's 1/4. This pattern, okay, what this pattern is that the slopes between the function and an inverse function at one related point, one point in its inverse, okay, the slopes are reciprocals of each. So if you know a point and the slope at that one point, then you know what the point and the slope is of the inverse function. So for example, over here, the function here at 2, 4, the slope is 4 at x equals 2. On the inverse function, okay, the slope, this slope right here, the slope of this function at one point, the slope is going to be 1/4 at x equals not 2, okay, but it's the x value of that related point. Okay, so in this case, this will be x equals 4. Okay, so notice how we're using 2 here. Notice how we're using 4 here. The slope is 4. We have a reciprocal slope at that connected point on the inverse function. Okay, all right, so that's it for page 1. We'll get to page 2 next.